Okay, question 6. Again, quite a big question, an 8-mark question. We've been given 2 curves, but with some missing values in one of the curves. It says point P lies on both curves. In other words, these curves cross at a particular point, and that point is P. And P has the x-coordinate 2. So P is 2 something. And they're on both curves. So what can we do initially? Without even reading on at this point, we can substitute 2 into both of these equations and see what happens. So if we substitute 2 into this equation, we're going to be able to work out the y value. And that's going to be 8 take away 7 plus 18. 8 take away 7 is 1. Natural log of 1 is 0. So the y coordinate is actually 18. So the full coordinate for P is 218. So we can sub that into here now and get hopefully some sort of relationship for A and B. So we know that we're going to get 18 when we sub it in for the P point here. We're going to get 2 squared, so that's 4 plus b to the power of a half. Or we could write that as a times the root of 4 plus b. So that's as far as we can go without reading on. It says it is given that the gradient of C1 is equal to the gradient of C2 at P. So if we differentiate these things, they're also going to have the same value. The gradients are equal. So if we differentiate each one, well, again, if we differentiate this one and sub 2 in, we're going to find the gradient value, and then we can use that on the gradient function for the second equation. So this was for C1, this was for C2. So let's do dy by dx for C1. If we differentiate a natural log, we can use the chain rule on this. We're going to get 1 over 4x take 7, but times by this, the differential of this, because we've pretended it's an x, so that's going to be timesing by 4, so it's going to be 4 over 4x minus 7. Differentiate 18, we get 0. So if we sub 2 in, if we sub it at P, dy by dx is going to equal 4 over 4 times 2, so that's 8 take away 1 again. So that's, 8 take away 7, which is 1. So the gradient at P, we know, is 4. And it's going to be 4 on this function here as well. So for C2, dy by dx is going to be, so what do we get when we differentiate this? We're going to, again, pretend this bracket's an x and differentiate it. A is just a constant, so that's just going to stay at the front. So we're going to have a times by, we're going to take the power to the front, the power's a half. We're going to take 1 off the power. It's going to become negative a half. But we're also going to times by the differential of the bracket. So times by 2x. So if we neaten that up, if we tidy that up, we're going to get the half and the 2 are going to cancel. So we're going to get ax, x squared plus b to the power of negative a half. Or again, without writing that as a fraction here, we could write it as ax divided by the root of x squared plus b. And we can now say that we know when we substitute 2 in, we're going to get 4. So 2a over 2 squared, so 4 root of 4 plus b needs to equal 4. So we've generated a pair of simultaneous equations. We know from here that a root 4 plus b needs to equal 18, and we know from here that 2a over 4 over the root of 4 plus b needs to equal 4. So how are we going to solve this now? Well, if we times this equation by root of 4 plus b and divide by 4, we're going to get that a over 2 is equal to the root of 4 plus b. And over here, we can say something about the root of 4 plus b as well. The root of 4 plus b is going to need to equal 18 over a. So we've got a relationship there. We can now say two things that the root of 4 plus b equals. So a over 2 also needs to equal 18 over a. And if we get times by 2 and times by a, we're going to get that a squared needs to equal 36. So a is the root of 36, so plus or minus 6. If we go back up to the top, it says that a and b are positive constants. So even though we've got initially two possible values for a actually has to equal 6 since it's a positive value. So that's our a value. We know that b is, well, we can use this relationship here to get b, or this one. We know that the root of 4 plus b is equal to 18 over a, but a is 6, so the root of 4 plus b is equal to 3. So if we square that, we're going to get that 4 plus b is equal to 9, and so b is equal to 5. So we've got that a is 6 and b is 5.